Okay, so most of you have taken either ACT or SAT before you came to college, right? Now, if somebody says that your SAT or ACT score is 70th percentile, what does it mean? If your score is if your score on SAT is 70th percentile, what does it mean? Anybody knows? I'm sorry? Not quite yet? Yeah, it's more precisely what it means is that so if your SAT score is 70th percentile, it means that 70% of the students scored at or below your score. Is that making sense? 70% of the students scored at or below your score. So generally, let's take a P to be a number between 0 and 1. So P is, so if you are talking about the 70th percentile, as in my example, P is 0.7. If I am talking about 20th percentile, then P is 0.2. Okay? 30th percentile would mean P is 0.3 and so on. So take a number P between 0 and 1, and 100th percentile is the value such that at least 100% of the observations are at or below this value, and at least 100 times 1 minus p% of the observations are at or above this value. I have to close OneNote, start it again. All right. Okay, so here, so for example, if you take P to be 0.8, then 100P would be what? If P is 0.8, 100P is 80, right? So if P is 0.8, we are talking about 80%. So if P is 0.8, let's see what this definition is going to be read as. So if P is 0.8, then we are saying 80th percentile is the value such that at least 80% of the observations are at or below this value, and at least 20% are at or above this value, right? Everybody understands the definition here? Okay, so there are some particular percentiles that are of particular interest. So these are called quartiles. So what are the quartiles? Quartile simply means one quarter, right? So first quartile will be denoted by Q1, and that's the 25th percentile. Second quartile is Q2, will be denoted by Q2, and that's just the median. That is the 50th percentile. Median is the 50th percentile. And the third quartile is Q3, and that's the 75th percentile. So the third quartile is denoted by Q3. So let's read out the definition of the third quartile. So this is the 75th percentile, right? So what does that mean? This value is such that 75% of the observations are, at least 75% of the observations are at or below this value, Q3, and at least 25% of the observations are at or above Q3, right? So I have this I made a picture for you. So think about, let's say that the observations, so I am denoting here the observations by x1, x2, xn. Okay, so maybe maybe this is this is xi, this is xj, this is xk. So the observations here are denoted by x with the subscript, and x1, x2, x3, they are in increasing order. That means x1 is less than x2, x2 is less than x3, and so on. And xn is the largest observation. So the picture that I made here, I labeled, I have Q1, Q2, Q3 in the middle. So Q1 is the 25th percentile, Q2 is the 50th percentile, Q3 is the 75th percentile. So this is a picture that I made to just put it in my head to remember what Q1, Q2, Q3 is. So Q1 is the 25th percentile. Q2 means, about at least 50% of the values are at or below that, and Q3 is the 75th percentile, meaning at least 75% of the observations are at or below Q3. Is everybody clear? Now the question is, how do you calculate this percentile, right? So how do we calculate percentiles? So in order to calculate the percentile, we have to look at two cases. So the very first thing, just in the case of the median, you had to arrange the observations in increasing order. We do the same thing here. We arrange the observations in increasing order. Let's say we have n observations, and let's label them as x1, x2, xn. Once again, we are arranging them in increasing order, so that means that x1 is less than x2, x2 is less than x3, less than xn. We want to calculate the 100th percentile. P is between, remember, 0 and 1. We want to calculate 100th percentile. In order to do that, the first case we look at is when n times p is not an integer. What is n? N is the data size, right? N is the size of the data. N is the number of observations, right? So the first case is look at NP and if and check if NP is not an integer. So if NP is not an integer, then what is the 100th percentile? Well, the 100th percentile in this case is given by the observation with index equal to the ceiling of NP. Now that symbol that I have around NP, right? I have kind of like square brackets, but I don't have the horizontal lines below are missing, right? So this is symbol that I have there. So I'm talking about this symbol. So writing something like 3.42 and writing this symbol, that's called the ceiling function, ceiling of that number. What is the ceiling of NP? The ceiling of NP is the following. So look at this number line that I have. So ceiling of NP means it's the smallest integer greater than or equal to NP. So what's the ceiling of NP? It's the smallest integer greater than or equal to NP. So think about on the number line you have NP, On the number line, you have NP right here, and then there is an integer right below it. There is an integer right above it, right? Is that making sense? In that case, the ceiling would be 4. Okay, and if you know about the floor function will give you the other integer, right? The floor of NP will be so the floor is written this way. The floor is written this way, and the floor of a number is the greatest integer smaller than that number. Okay, so in the case of NP, you know, this is the floor. This is the floor, and the other one is the ceiling. So if I have the number 3.21, right? For example, if I have the number 3.21, what's the ceiling of that? The ceiling of 3.21 would be 4. What would be the floor of 3.21? 3. What if I have just the number 3? What's the ceiling of 3? 3. Okay? Is everybody clear? So, in the case where NP is not an integer, okay, then the 100th percentile is given by the observation whose index is given by the ceiling of NP. Okay? What's the other case? The other case is that NP is an integer, right? The other case is NP is an integer. Well, in that case, the 100th percentile is going to be the average of the two observations whose indices are given by NP and NP plus 1. Okay? So it is the NPth observation and the NP plus the first observation, and you take the average of that. Is everybody clear? All right, let's do some examples, and then it will be clear how this is how we can calculate the percentiles. So here I have an example. The data is given in the table, and I have numbered the data values or the observations. So how many observations do I have in my table? 50, right? I have 50, so n is what? N is 50, right? And let's say I want to find the Q1. I want to find Q1, that's the 25th percentile. In that case, what's the p-value? In that case, p is 0.25, right? I want to find the 25th percentile, so p is 0.25. Obviously, 100p is 25, right? 25th percentile. What is n times p? N times p would be 50 multiplied by 0.25, right? What is that equal to? What's that? 12.5. Is that an integer? No, so we are in case 1. NP is 12.5, is not an integer, so Q1 is given by which observation? It's given by the observation whose index is what? The floor. So what's the floor? Sorry, not ceiling. What's the ceiling of 12.5? The ceiling of 12.5 is 13, right? So So basically we look at the 13th observation, and the 13th observation is what? The 13th observation in my table is what? Can everybody read the numbers there? What is it? 276. Is everybody clear how we got that? Remember, you have to arrange the observations in increasing order first, which is done in my table. Okay. All right, let's look at Q3. What is Q3? Q3 is the 75th percentile. So for Q3, P is 0.75. Therefore, N times P in this case will be 50 times 0.75. And 50 times 0.75 is 37.5. And 37.5, what's the ceiling of that? 38. So the Q3 would be the 38th observation, which is in our table 323. Is everybody okay with that? All right, let's also calculate Q2. We already know Q2 is median. We already have a way of computing the median, right? But let's just do it in this way. Well, Q2 would be the median, so what is P here? That's the 50th percentile. So P would be 0.5. So in this case, what is NP? 50 times 0.5, which is 25. Well, this is an integer, right? If this is an integer, we are in case 2. In that case, what do? We have to take the average of the two observations, which are the 25th and the next one, 26th observation, right? So average of the 25th and the 26th observations. And we know that 25th is 303 and 26th is 304. And you take the average of the two, you get 303.5. Is everybody okay with that? Any questions on how you can calculate the percentiles? Everybody's okay? All right, so